Bismillahirrahmanirrahim. In today's slide, we are going to discuss about the charged particle production in particle physics. So, how charged particles production? Basically, the creation of charged particles. What charged particles? Which charged particles? Such as you know that protons, electrons, these are charged particles. So, the creation of charged particles such as proton and electron during the high energy collision, such as those in proton-proton collision at the LHC. So this is called as the charge particle production. You know that in LHC we are going to collide proton and proton. So after the when the collision at high energy is like 13 tera electron volts. You know this is the max achieved collision energy at LHC. So by colliding the proton-protons, the creation of particles such as more particles for more fundamental particles is known as the charge particle production. And the key concept of particle production we will discuss. First of all, we discuss the multiplicity. What is multiplicity? Is the total number of charged particles produced in the collision event. Okay, and this multiplicity reflects the event's complexity and the energy transfer. So the number of charged particles produced after the collision of proton-proton, let's suppose, in an event collision is known as the multiplicity of particles. The total number of charged particles production is known as the multiplicity. And the second parameter is the pseudo-rapidity, which is represented by this symbol is known as eta. This is known as pseudo-rapidity. And what pseudo-rapidity describes is the angle of the particle emission relative to the beam axis. So the angle of particles emission relative to the beam axis, you know that the z-axis is the beam axis in at LHC. So the angle of particle production emission relative to the beam axis is known as eta, which is called as the pseudo rapidity. And this pseudo rapidity is very important for understanding the angular distribution of the particles. And here is the relation of eta. Eta equals to minus ln tan theta over 2. Okay, and the last parameter we are going to discuss is the transverse momentum. What is transverse momentum? Is the momentum of particles perpendicular to the beam axis, or you can say the beam line. Again, the z-axis is the beam line. So the momentum of particles perpendicular to the beam line is known as the transverse momentum, and this is denoted by pt. Understood? And this transverse momentum is very valuable for understanding the particle energies as well as the jet formations. Okay, high jet formations at high transverse values, high pt values. More particles produced if there is more pt. Okay, so here is you can see the relation pt equals to p sine theta. Understood? So that's all for our today's slide. We will discuss more further interesting facts about the particle physics in our upcoming slides. Till then, take care and Allah Hafiz. Thanks for watching.